All right, class, this is example 3, constructing a prediction interval. As of yet, there is no easy way to do this on the calculator. The only way requires you to use this formula right here, and then using it to figure out what your differences in your y are when given a certain x value. So for this problem, we're given the x value 3.5. This is again from the data, from the GDP data that correlates to the CO2 emissions. So make sure you have that data in your calculator. I still have it in mine. I'll bring it up here. It is this stuff, and I got some other stuff here. You can use all this stuff, but really the only thing we need are L1 and L2, so I still have this in my calculator. Okay, so we're trying to figure out, like, here's our, I'll just kind of go through this problem real quick. So we did a linear regression. Whoops, calculate, linear regression, hit enter. Okay, I want L1 and L2. And I want to store this as a function, y1. Calculate. Okay, so here is our m value, our slope, and here is our y-intercept. And I just stored that in y1. So I'm going to go to my window. I'm going to clear out all this other crap I got in here. All right. Okay, so I'm going to go to my window, and my x values, my lowest one is about 0.8, so I'm going to go 0.5. My highest one is, let's go 6.2. And my lowest y value, we got 250, 253, so I'll go 250. My highest value will go 1200. Okay, and we'll have this be just 100 just to make sure we don't have too many lines. All right, so if I graph this, there we go, there's our linear regression. We've seen this before. So we're supposed to predict, for this problem, it says construct a prediction interval. Okay, with 95% accuracy. So if I just enter in the value 3.5, what do I get? Okay, I get a value of 699.876. Okay, but how accurate is that? Well, we don't know. Just like all these other problems we would do in the past, we're going to find a 95% interval, meaning that 3.5 isn't probably going to be exactly, what, 700 CO2 emissions. A 3.5 trillion GDP isn't going to be exactly, it's going to have a confidence interval. It's going to be somewhere between here and here, and we can be a level of certainty to that. So this problem that says, well, with 95% certainty, tell me what this is supposed to be. So we got 699.876. Roughly, the book has 875. So 699.876. How close is this? We want an interval, so something less than this, and something more than this, where we can guarantee that with 95% confidence that we're going to have a value in that range. So how do you do all that? Okay, well, the hard work is already done. We got to do a little bit more here. Let's do this first. First thing we need to do is find the critical value with 0.95. Okay, so this is a critical t value. This is two-tailed. Okay, but I want the positive one for this problem. In the formula, there's no easy way to do this. In this formula, it uses the critical value, but it uses the positive version. Okay, so I want to have the positive version. How do I do that? Well, I need to know all of this area up to this little line. So 0.95 is what's between these two lines. So if I add on this little bit here, that should give me this critical value, right? The area. Okay, if you remember, we've done this before. We go to vars, number 4. Oops, I don't want to do it in here, so quit out of that. Let's try that again. Go to vars. Nope. Second vars, distribute, number 4. Okay, so I want 0.95 plus 0.95 plus this little bit right here. What is that little bit? That little bit is half of 1 minus 0.95. There's other ways to calculate this, right? If this is 0.95, this area plus this area would be 1 minus 0.95. Okay, but I only want one of them, so that's why I'm dividing this by 2 or multiplying it by a half. Okay, degrees of freedom, we have 10 pieces of data, okay, from our list, but it's 2 sets of data, so we have to minus 2, so this would be 10 minus 2, that's how you get a degrees of freedom of 8. Go to paste, hit enter. Okay, here is our critical value that we want. Okay, all the other values will come from running tests linreg t-test. Okay, this is where we're going to get all the other values. Hit enter. They're all stored here now. So now I can enter that equation. The first one I'm going to use is this number. Click on it. The second one I'm going to use is my standard error. Okay, that's going to show up in number 5. It's S. It's this S right here. Okay, hit enter. Take the square root. And I'm going to, well, it's just 1 plus. The next one is a fraction. And once you put this in your calculator, you can kind of keep referring to it. So it's 1 over n. Go back to vars. Number 5. N is the first one there. Plus another fraction. Okay, this time we want n again. Again, if I'm going too fast, if you're not following along, just pause and rewind. Parentheses. Okay, x naught. This is our 3.5. This is the value we're supposed to find. So put in 3.5. Minus x bar. Again, go back to vars. Number 5. X bar is number 2. Okay. And this is squared. So all of these values showed up because we ran the linreg t-test. If you don't run that, then these values are going to be different. These values are going to be from a different problem. So you got to run that first. Okay, so again, now we're doing the bottom here. The bottom is n. So I go back to vars, number 5, n. This symbol is the sum of x squared. So go back to vars, number 5. This I'm going to go to the sum of x squared. I want that one. Be careful to pick this one and not just the first one and then square it, because we're going to do that actually here in a second. I'll move this over so we can see it a little better. Okay? All right. Now we minus sign. Okay, and now we want parentheses. I want the sum of x. Okay, so go back into vars. Number 5. The sum of x. This is the first one. And then we're going to square that. Okay, so quite a little bit here we got to do. Hopefully this pulls up to be the right answer. This should be 288, which it is. Okay, and now we're going to take our original value of 699.876. Okay, oh, where did my calculator go? Here it is. So 699.876. And I think I actually have that stored as x, do I? Oops, nope. Uh-oh. Okay, delete that. All right, so we're still tracking. I'll just check something. Nope. Okay. All right. Anyways, so we can just enter this 6, 99.876. And we're going to add that number. Hit enter. And we're going to subtract that number. Hit enter. Okay. It might be a better way to do this. So we got that value of, so if I go to second trace, value, number 1, 3.5. Whoops. Okay. Wonder how that one shows up. Oh, this should be good enough. Okay, so our range then would be 410.995 to 988.757. The book's a little bit off. This would be with 95% confidence interval. If you read through the chapter, it explains this a lot better than I'm capable of in a 5 to 10 minute video. But this should get you going on the problems. I think there's a better way to get this number, and I'll explain that in a later video, but I'm not going to take up any more time with this one. So hope this helps. Probably going to have a lot of questions on this, but just follow the formula.